Access policies. 1. This option only influences how you assess bucket policy permissions. 2. When activated, it disregards any buckets or objects having public permissions granted via bucket policies. 3. On enabling this setting, access to a bucket with a public policy is restricted to only AWS services and authorized users within the bucket owner's account. 4. This setting blocks all cross-account access to a bucket with a public policy, except by AWS services, while still allowing users within the account to manage the bucket. 5. It doesn't modify existing bucket policies, but it does ignore any existing bucket policies that grant public access, thereby blocking public access and any cross-account access configurations. 6. Keep in mind that with this option enabled, if you have any ACLs granting public access to buckets and objects, they will remain publicly accessible. 7. If you wish to block all public access to buckets and objects, opt for the Block All Public Access option. Bucket policies. 1. In order to grant other AWS accounts or IAM users access to the bucket and the objects within it, a bucket policy needs to be attached. 2. As you are granting access to a user or account, a bucket policy must define a principal, which can be an account, user, role, or service. The principal statement is typically listed within the bucket policy. 3. When using bucket policies, the security is managed by Amazon S3. 4. Bucket policies can supplement and, in many cases, replace legacy ACL-based access policies. 5. Amazon S3 supports a bucket policy size limit of up to 20 kilobits. When to use a bucket policy. 1. Need to grant cross-account permissions to other AWS accounts or users in another account, without using IAM roles. 2. Encounter situation where IAM policies reach the size limits for users, groups, roles. 3. Prefer to keep access control policies in the Amazon S3 environment. 4. Both bucket and user policies support granting permission for all Amazon S3 operations, however, user policies are primarily for managing permissions for users in your account. IAM policies. 1. Use IAM to manage access to your Amazon S3 resources. 2. Create IAM users, groups, and roles in your account and attach access policies to them, granting them access to AWS resources, including Amazon S3. 3. Understand that there are maximum size limitations for IAM policies for users, groups, and roles. IAM policies have a 2 kilobit size limit for users, 5 kilobits for groups, and a 10 kilobits for roles. 4. Notice that there is no principal stanza listed in the user policy, as the principal is whichever user the policy is applied to. When to use IAM user policies. 1. Control access to AWS services other than Amazon S3. IAM policies allow for easier centralized management all of your permissions. 2. Manage numerous Amazon S3 buckets, each with different permissions requirements. IAM policies will be easier to manage than having to define a large number of Amazon S3 bucket policies. This way you can focus on having fewer, more detailed IAM policies. 3. Prefer to keep access control policies in the IAM environment. Presigned URLs. 1. By default, all objects and buckets are private. Only the object owner has permission to access these objects. 2. The object owner can share their objects with others by creating a presigned URL. This grants time-limited permission to download the objects. 3. When creating a presigned URL, you must provide your security credentials, specify a bucket name, an object key, an HTTP method, put for uploading objects, and an expiration date and time. 4. Anyone who receives the presigned URL can access the object. For instance, if you have a private video in your bucket, you can share it by generating a presigned URL which is valid for a limited period of time. 5. Presigned URLs can be used to grant temporary access to Amazon S3 resources. They can be embedded in websites, used in command line clients to download objects, or generated programmatically to allow a user to upload an object to a bucket. Presigned URLs, some considerations. 1. Individuals with valid security credentials have the ability to create a presigned URL. 2. To ensure successful access to an object using this URL, it should be created by someone equipped with the required permissions. 3. There's a variety of credentials you can employ for creating these URLs. An IAM instance profile valid for up to 6 hours, the AWS Security Token Service, which when signed with enduring credentials like those of the AWS account root user or an IAM user, lasts up to 36 hours, and the IAM user itself, which remains valid for as long as 7 days when using AWS Signature version 4. 4. It's worth noting that if a presigned URL is generated using a temporary token, its expiration will be in tandem with the token's own expiration, despite any later expiry time denoted during the URL's creation. S3 Object Ownership and Features. 1. S3 Object Ownership, originally belonged to Uploader. 2. Ownership Change, new AWS feature. 3. Amazon S3 Object Ownership has 2 modes. 4. Object Writer, the account that is writing the object owns the object. 5. Bucket Owner Preferred, the bucket owner will own the object if uploaded with the bucket owner full control canned ACL. Without this setting in canned ACL, the object is uploaded to the bucket but remains owned by the uploading account. S3 Object Ownership and Bucket Policy. 1. After setting S3 Object Ownership to Bucket Owner Preferred. 2. You can modify the bucket policy to require all Amazon S3 put operations to include the bucket owner full control canned ACL. 3. This ACL gives the bucket owner complete control over new objects, and combined with the S3 Object Ownership setting, it transfers object ownership to the bucket owner. 4. If the uploader fails to include the required ACL in their upload, the request will fail. 5. This mechanism enables bucket owners to enforce uniform object ownership across all newly uploaded objects in their buckets. Access Analyzer for Amazon S3. 1. On the Amazon S3 console, Access Analyzer for Amazon S3 can be utilized to review all buckets. 2. Access types can be access control lists, ACLs, bucket policies, or access point policies that allow. 3. Access levels can be public or shared access. 4. Access Analyzer for Amazon S3 sends alerts about buckets configured to grant access to anyone on the internet or other AWS accounts, including AWS accounts outside of your organization. 5. For each public or shared bucket, findings are provided that report the source and level of public or shared access. Encrypting data. 1. Data protection is about safeguarding data during its transit, data traveling to and from Amazon S3, and while at rest, when it's stored on disks in Amazon S3 data centers. 2. Data in transit can be protected using Secure Socket Layer/Transport Layer Security, SSL/TLS, or client-side encryption. Providing the appropriate level of protection for your data in transit ensures the confidentiality and integrity of your workload's data from potential interception while in transit. 3. The AWS API is a REST service that supports SSL/TLS connections, hence all official AWS SDKs and CLI tools connect to the AWS API using SSL/TLS by default. 4. For data at rest, data already stored on disk, Amazon S3 offers 2 options: server-side encryption, and client-side encryption. Server-side encryption. 1. When using server-side encryption, Amazon S3 encrypts an object before it is stored to disk and decrypts it when you download the object. 2. Provided that you are authenticated and have the necessary access permissions, there is no distinction in how you access encrypted or unencrypted objects. 3. If you share your objects using a presigned URL, that URL operates identically for both encrypted and unencrypted objects. 4. When you list objects in your bucket, the list API returns a compilation of all objects, regardless of their encryption status. Server-side encryption with Amazon S3 Managed Keys. 1. The server-side encryption with Amazon S3 Managed Keys, SSE S3, is used to encrypt objects. 2. With SSE S3, each object is encrypted with a unique key. 3. The unique key is further encrypted with a master key that is regularly rotated for added security. 4. Amazon S3 server-side encryption employs 256-bit Advanced Encryption Standard, ICE 256, one of the strongest block ciphers available, to encrypt data. Server-side encryption with AWS Key Management Service. 1. Server-side encryption with Customer Master Keys, CMKs, stored in AWS Key Management Service, SSE KMS, is an encryption service similar to SSE S3. 2. SSE KMS offers additional benefits over SSE S3 and charges may apply for using this service. 3. With SSE KMS, there are separate permissions for the use of a CMK, providing added protection against unauthorized access to your objects in Amazon S3. 4. SSE KMS provides an audit trail that shows who used the CMK and when it was used. 5. You have the option to create and manage your own customer-managed CMKs, or use AWS-managed CMKs that are unique to your service and your region. Server-side encryption with customer-provided keys. 1. With server-side encryption with customer-provided keys, SSEC, you have the ability to manage your own encryption keys. 2. Despite you managing your own keys, Amazon S3 still takes care of the actual encryption as it writes to disks, and the decryption when you access your objects. 3. With SSEC, the responsibility of managing and rotating the keys falls to the customer. 4. Without access to these customer-provided keys, the data stored on Amazon S3 cannot be decrypted. Client-side encryption. 1. Client-side encryption refers to the process of encrypting sensitive data before sending it to Amazon S3. 2. With client-side encryption, the encryption operation is performed locally, meaning your data never leaves your run environment in an unencrypted state. When using client-side encryption, you maintain possession of your master encryption keys, and they are never sent to AWS. 3. It is crucial that you safely store your master encryption keys, i.e., as a file or using a separate key management system, and load them when uploading or downloading objects. 4. This approach ensures that no one outside of your environment has access to your master keys, and without access to the master keys, your data cannot be decrypted. 5. If you lose your master encryption keys, you will not be able to decrypt your own data. Therefore, if you use client-side encryption, it is vital that you store your keys safely. Enable client-side encryption. 1. You can use a customer master key, CMK, stored in AWS Key Management Service, AWS KMS. In this scenario, an AWS KMS CMK is utilized for client-side encryption when uploading or downloading data in Amazon S3. 2. Alternatively, you can use a master key stored within your application. With this approach, you provide a client-side master key to the Amazon S3 encryption client. The client uses the master key solely for encrypting the data encryption key that it generates randomly. Thanks for watching.